The broadcast is now starting. All attendees are in listen-only mode.
Hello and welcome to the EuroSTAR December webinar series. Today's presenter is Kristian Karl, and he will be presenting experiences of test automation at Spotify from his presentation at the EuroSTAR Conference 2013 in Gothenburg. If you have any questions for Kristian, please type them into the questions field on your control panel, and I will address these questions to Kristian directly at the end of the webinar. You can type your questions at any point during the course of the webinar. The webinar slides, as well as a recording of the webinar, will be available on the EuroSTAR website shortly after the webinar ends. You can join the conversation on Twitter using the hashtag ESConfs, and you can connect with EuroSTAR using the Twitter handle @ESConfs, and you can also connect with Kristian by using the Twitter handle @Kristian Karl. I will now hand you over to today's presenter, Kristian. Hello, Kristian.
Hello. Hi. So, technical difficulties, but now I'm all set, and I welcome you all, and I hope that you can hear me well. Otherwise, Dara will let me know. So, before I start, I will do an introduction of myself, but I would also like to do a poll, and I will ask you to do this poll for me while I do my introduction. So, as Dara mentioned, my name is Kristian Karl. I work as a test manager at Spotify, and I've been working here since October 2010. This will make it my fourth year here, or well into the fourth year, and it's been for me an amazing journey. I started with test automation in the '94, working at Ericsson, and learned my ways of doing testing the old-fashioned telecom way. And interestingly enough, I started right away doing test automation, and I did test automation 10 years, very much the traditional way. 4 years after starting at Ericsson, I left to go into the business as a contractor, as a test consultant, and I did that for various types of businesses, for government, for finance, and for startups. But in 2004, I believe, I had an epiphany when I listened to the keynote or actually it was a workshop by Harry Robinson at the STAR East conference in Florida, Orlando. And he talked about model-based testing, which was for me like the answer to many, at least, questions or problems that I had doing traditional test automation. So part of my test automation is inspired by Harry Robinson and model-based testing. Well, enough said of me. Let's start, and let's see. Has everybody voted? You will get the last chance. Let's do it like this. I'll present you the second slide and tell you a little about Spotify. Spotify is a very interesting place to work at. It's a sort of a startup.
Sorry, Kristian. Sorry for interrupting you there. Just for the attendees to view the next slide, we're just going to have to close the poll here.
Great.
So I'm just going to close the poll here, and if you want to share the results, you just click on the share button, and you can go from there. Just sorry for that little quick interruption.
No problem. So let's look at the results. We have 54% of testers, 36 test automators, 36 test manager, and 1 project manager. Great. This is for me interesting. So let's go on with Spotify. So when I joined the company, it was pretty much a startup, and we pretty much started at that point to do Agile seriously. And 3.5 years later, we are a company which has grown from the year I joined the company. We were 25 in tech, and now we're about 500 people in tech, which is an amazing organizational growth. One thing that is really interesting for me as a tester and a test automator is the way we do Agile, and we do really have autonomous teams which decide how to do things or how to decide. There are some constraints that we impose on them, and it's, well, we use Git or GitHub for source control. We don't have too many, we don't let the teams get too dispersed in program languages, and we do need to do code reviews. Other than that, it's pretty much up to the teams to decide how to work. And in order to facilitate the agile environment, so to speak, we have organized, or we have, when we moved into our new office space in Stockholm, we designed the office space to facilitate agile. It means that on the left upper corner we can see a picture of a team room, which is like an open space, but it's like fenced in just for that team. And that team has its own stand-up areas with whiteboards, and they also have their own conference room, which is not bookable by any other teams. And the test team at Spotify has grown pretty well. We have in the lower left corner a picture of the members joining an unconference that we had. An unconference is a sort of a conference where we map the agenda of the day in the 2 first hours together, and we vote and we go to whatever topic we see most interesting. It was a very successful conference. Lower right, it's just to show you how crazy people are at Spotify. I was actually working, and these 2 guys sneaked up to the left of me and just said nothing. Very scary. I don't know who these people are. I have some suspicions. All right. This is a slide that shows how we organize ourselves in the tech department. Everything is about what we call squads. Squads are cross-functional teams, and cross-functional means that they have any skill set in the team as they need, depending on what mission the squad has. Every squad has a product owner, and every squad has an agile coach. The product owner owns the backlog, the requirements, the roadmap, so to speak, the prioritization of the tasks, and the agile coach it's not a scrum master. It's a person that can act as a scrum master if the team wants him to, or her. It's more a person who facilitates the process between people within the team, and I must say that has been very successful for us at Spotify. Me, myself, am a manager for the QA chapter in one of our tribes. A tribe is a sort of way to section. I mean, when we get too many peoples, we don't want the middle management to become bottlenecks, so that's why we found ourselves necessary to break us up in tribes. So this is pretty much how it looks like. In order to keep, or rather not to invent the wheel unnecessary many times, we have guilds. And guilds are defined as a community of interest. It means that if I'm interested in testing, or indeed a member of a QA chapter in any tribe, I'm very much a part of the guild, QA guild. Me personally, I'm a member of the Test Automation Guild, the Testing Guild, which is called the QA Guild. And by the way, let me just mention for you, QA at Spotify doesn't mean quality assurance. It stands for quality assistance, which is a different thing. And also I'm part of the Continuous Delivery Guild, or Continuous Deployment Guild. For those of you who perhaps don't know what Spotify does, we are a music streaming business, so These are the things that you might or might not have seen. It's different kind of platforms and client that enables you to listen to your favorite music. And this speech today will mostly talk about the kind of automation you would apply upon these interfaces or these tools, clients. Now, for the automation part, why would we do automation to begin with? From management level, they always wanted us to move faster. That was the first thing they asked me when I started or during the interview process at Spotify. Can you give us automation? Now, the reason for doing automation is that we want to move faster. We want to do and we want to deliver features and new cool stuff and give it to our end user as fast as possible, with the quality still in mind. This is like a competition edge that you want to keep. You don't want that your competitor will come up with a cooler solution that you might have. Also, automation enables to give a quick feedback loop to developers. It's one thing to say to a developer 2 months or 3 weeks after he developed a piece of code and say that and give him the feedback that this piece of code didn't really work. Now, automation would perhaps enable us to give the developer quicker feedback in order to say that the things still work or that they broke. Of course, this will enable the developers to get more comfortable and secure in doing refactoring and try new stuff which they might else not have tried and dared. Ultimately, we want to reach the continuous delivery or continuous deployment goal. We want to go from commit to deployment to customer as fast as possible. We actually do that today. Not all teams. I'm not sure how many squads we actually have at Spotify. I would guess about 50. The squad responsible for the WebPlayer, they actually are enabled. They can do continuous deployment. They can go from commit to customer in a few hours. I would say, I think the time is about 3 hours if they want to, and they have actually done that a couple of times. Continuously monitor the state of the product. That actually means that we don't just do continuous delivery, or we don't just do automation in order to do continuous delivery. We also want to find actual bugs, and the last bullet point are bug hunting. Now, if we just run a single path through our system under test, it will only find bugs that perhaps is in that way. That is good for monitoring, but we need to find different solutions for actually bug hunting as well. So that applies different techniques, or that would mean that you would apply different techniques to achieve just that. Now, what can you automate? You can automate a lot of things, of course. And the most common thing to automate, I would guess today, is unit testing, which is per definition automated already. And you can go all the way up to the graphical user interface testing, which is what I will be talking about today. So let's see what kind of goals we set up for ourselves. We wanted to have automated end-user acceptance tests on our 4 major platforms. And those are the desktop, which includes both Windows and OS X platform, our iPhone client or iPad client running on iOS, our mobile Android and tablets, and of course the web player. Another important goal was that the tests were there not to replace the testers. That was never our goal and will not ever be our goal. The tests, the automation, is rather a way to facilitate and help the testers. What we want primarily is for the testers to focus on whatever is the change set of the system under test. So if the commit is about, let's assume perhaps playlist, we want the testers to focus on testing the playlist because that's where the change was in, and have all the automation to verify that the other functionality still works, and not having the testers to spend so much time there. Now also a goal, very important goal, was to, as a part of definition of done, also include automated regression tests as an artifact of definition of done. And also to have some sort of way to convey the state of the system under test, some sort of dashboard that would display easy enough understandable results from the testing for the whole team, for the product owner, for the developers, and for the testers and test automators. We had quite a few challenges doing this. First of all, we had a very difficult system under test. This includes the whole software stack from databases, backend systems, all the way up to our desktop clients. Now, our desktop client, for instance, is programmed in a way that every single control, like list box, edit boxes, combo boxes, and buttons and whatnot, they all render in the same window. That's the whole client area of the client, which means that any ordinary test tool, like for instance Quick Test Professional or Functional Tester, they can only see one window and nothing within it. So that was a very hard nut to crack. There's a very good case study made by Dorothy Graham and Mark Fuster in their book Experiences of Test Automation. I would recommend that book if you have a system that is hard to test, also how to approach that kind of situation. It's the first case study in that book made by Lisa Crispin, an agile team's test automation journey. I highly recommend that. Another challenge is if we succeed with the first one, how to handle the biggest problem of test automation, which I would consider to be the maintenance. I mean, it's software in its own right. The coding will produce, I mean, we need to handle that code with the same care as we do with our system under test code. So there's different aspects about that. Expectations. Now, you will get different expectations from different team members and roles within your squad. The product owner will have one set of expectation of the test automation, the outcome. The developers will have different expectations. Typically, I could mention that developers are more technical in their approach and what they expect. They are more into running test automation in a way to find corner cases, to find resource leaks, for instance, whereas product owners more would like to know, are we ready to ship, for instance? Is this good enough? And test automators and testers, or testers by all means have I mean, the whole team or squad can have a different set of expectations. So what one needs to do is to leverage that expectations and really be pedagogical on what to expect from the automation. Also, there's a cultural thing that needs to be understood, that things will change, and all change means some sort of resistance. Change, I could give you an example. It could mean that to treat bugs in a different way. A bug, for instance, could, prior to test automation, have been a lower priority bug. It could be a cosmetical thing. But during test automation, tests may fail because of these low priority bugs, and the tests will actually not run until that bug is found or fixed. It means that the team will need to change their approach to what stops the test, and everything, well, the bug needs to be a high priority bug instead, because things that stops our tests will prevent us from verifying that the system is actually okay or not. So those kind of bugs needs to be reprioritized. That's like a cultural thing that you need to make the team or squad to understand. Also, you need to get the team into the mode of creating testability or non-functional code that is there only to make the system easier to test, and that will add to the velocity of the team. Actually, it will decrease the velocity of the team if you measure it in terms of velocity, because you need to do more things that you might have done before. I forgot about flaky tests. So flaky test is not always flaky test. It could actually be a flaky system under tests. It touches the thing I talked about earlier about bugs. Test automation is not just going through the system using a specific flow or different flows. It's also about using different data and walking the same flow, which could mean a completely different test. So you need to have a good strategy to handle test data. And also, of course, the test environment and some other supporting services. So what I'm talking about here is an overhead that needs to be communicated to the team and also to management, because it will be more costly to do test automation. It's not just that the tools costs. They might be even open source and free, but you will need people actually coding, and that will always add to the cost. Right. First thing then, maintenance. This is my drawing. It's not very pretty, but it says one important thing. It says in the middle there, put on the vertical abstraction layer. This is a really, really important thing. It means that whatever tests we have, whatever design we have put in those tests, they should never be embedded in any kind of code. If we embed the test design in code, we will make it not very transparent to anybody else than whoever understands the code that the test has been written in. This enables us to use testers to be in charge over the test designs. The tester is the person who is in full control over what's being tested. Now, if we take a login scenario for a desktop client, it's a tester who should know or have a say, or at least understand what's important here to be tested. Now, the design is then handed over to the developer who then implements this. There are some different tools and methodologies that will help you with this. One very popular now is, for instance, the Cucumber or RSpec. They both use a domain-specific language to express the design of the test in some natural language, and then being implemented by, for instance, developers that will actually execute the code. What we do at Spotify, we do another methodology which is called the ModelBased Testing, which I mentioned earlier in the presentation when I talked about Harry Robinson. Now, for us, a model is the abstraction layer, and testers are designing the test using the models, and the developers are implementing the automation using the models as the specification. And at this point, I would like to show you what a model can look like. And imagine that you will design a test of the Spotify client, and we will design a test of the login scenario. Now, the login scenario is about, at Spotify, is that you can give valid credentials or you can give invalid credential, and if you have done a valid login and pressed the Remember Me button, that's a checkbox, you would, next time when you start the client, you would end up directly in the Spotify client. Now, if I would model this as a tester, I would do it like this. Now, this will be a finite state diagram, so I will start with an arrow. In a finite state diagram or a state graph, this is an edge. This means that I'm just doing something. I'm moving from one state into another state, and the state I expect to end up in is this. Now, this is a very, very simple finite state diagram. I move from one state into another. That's all that happens here. And in this box, which is called a vertex or a node, that's where we do our assertions. So in our test automation code, that is where we verify that this has happened. This is a way of expressing the expected behavior of the system under test. Now, if we were to elaborate on this model, I could enter valid credential in the login dialog, and I expect that the system would display the main view. I can then log out, and I would expect that we would end up in the login view again. I could try enter invalid credentials, but I would still expect to be in the same login view, perhaps with an error message. And if I toggle the Remember Me box, which is the checkbox, I would set it to true here. I could do that, and I can close that login the dialog, and I would end up in a state which I haven't mentioned yet, and this is the state that I expect to end up in. App not running. Now, imagine if we were in the state main view displayed, the box in the bottom here. If I exit the app, I would expect to end up in the app not running. Now, if I have done a valid login, and if the Remember Me checkbox was set to true, I would expect to end up in the main view display when I start the app again. This is how we design a test on an end-user acceptance level at Spotify. This is a finite state diagram, and this is model-based testing in its essence. It's an expression of the expected behavior of the system under test. You could probably do this as well in RSpec or in Cucumber. There's a nice thing, though, with these kind of graphs. They're very visual, and they're very good at displaying the flows. And there's other things as well. This is how the model probably would look like if you draw it syntactically correct. This is a model that would actually work at Spotify. I would like at this. Okay, sorry. Now, this is what the developer would see from the test automation design. He would extract by a tool the interface that needs to be implemented in order to run this test. So using GraphWalker, which is the tool that we use, GraphWalker will then generate this interface, and the programmer needs to implement each of these interfaces in order to interact with the system under test. Now, at this point, I would show you a demo. So I mentioned GraphWalker, and GraphWalker is an open source tool at GitHub. It also has its own website, and on the website there's a video, and that's the video I would like to show you right now. So consider this model. If you're able to read parts of it, it means it's a test of the shopping cart of the Amazon website. It's not a perfect test or test design, it's just a showcase of how modeling works and how it connects to some testing tool. In this case, it will be Selenium and the WebDriver too. So let me kick off the video. So I'm starting the test from Eclipse, And when the test has started, I also hook up back to GraphWalker using a second browser that we can see on the right. Now it uses the port 9191 and it connects to GraphWalker and it shows the model as we execute the system under test, which we see on the left, which is the site that we actually test. Let's see now. It's using Selenium WebDriver 2 in order to interact with the system under test. And this example, which ends there, this example you can download from GitHub if you just go to graphwalker.org, and you can run exactly this example on your desktop. The only thing that you need is Java and Firefox installed and Maven as a Java project handler. Now, I've been talking a bit about test automator. I might even have said test developer. Now, at Spotify, that means exactly this. It's a developer. It's not a person who knows how to program. That would be me. I would actually be not very good at writing test automation because I do know how to program, but that really doesn't make me to a programmer. And what a professional developer would actually give me is maintainable code. I would never dream, as a tester who knows the program, I would not perhaps know a thing about page object design patterns, which I expect a professional or a developer to know about. There's so many things that I would do that would cost us a lot of maintenance problems in the end. All test automators at Spotify are first and foremost developers. Some have previous testing experience and some have not. But the red thread here is that they all are developers. And one other thing, they are embedded in the squads. They need to be embedded in the squads. They are working there full time because their mission is, if you remember our goals, that was to deliver automated regression tests for the features as a part of definition of done. So they do the test automation of the features as they are being developed. And believe it or not, it's more common that the test automation is ready prior to the actual system under test. I have seen that many times at Spotify. Test automators form their own guild. It's a very active guild. It's Tuesday today, and we will have a guild meeting after this presentation, and it's a very active one. Now, there's a question here which we asked ourselves. Now, having one test automator for a squad that contains maybe 7 or 8 developers, why couldn't they do test automation? Now, the thing is that we want the developers to produce the system under test and perhaps the testability functions that we would need in order to test the system. So we would not like to decrease the velocity that we would get from the test automators. But what we found is that if we add something that we call perhaps, well, we call it the test APIs. I'm still talking about user interface testing on mobile platforms and web and desktop. For the web, we don't have any problems with the test APIs and testability in regards to the interface because we have the WebDriver from Selenium. But for the mobile platforms, we haven't had as good success with toolings as we had for the WebDrivers. There are good tools. There are good tools out there, like Appium, for instance, for mobile platforms, but they're not as stable as we would like them to be. What we found is that if we create our own test APIs defined by test automators, we can make the developers to implement them for us, and thus we will get more scalability when it comes to test automation and have the test automators to focus on the actual test automation problem and not so much about testability towards the system under test. Let the developers who work with the system under test to do that instead. And that has been very successful for us, and I will give you an example of that. Now, this is a typical example for both the Android and the iOS platform for us. This is how it used to look. We had some sort of a test interface, and we communicated with our clients using New Remote, which is an open source project, or Bean Shell on the client side, and we sent a couple of strings back and forth. Those strings were produced and written by the test automators. Not knowing everything about the client, we would get a lot of runtime errors, and the quality that we got from that was not very good, and we spent a lot of time writing that not very good quality also. Now what we did was that we defined these interfaces instead and had the developers to implement them for us. It's pretty much like we having our developers writing our own web drivers for us on the mobile platforms, and that has proven very, very successful for us. Now we will get compile time errors instead of runtime errors, and the test developers, test automators, can spend more time and making the tests more robust, and then focusing on code within the client that they're not master. And one other thing here is that the test automation that we're doing is written in Java, and our system under tests are written in different languages, and it doesn't really scale if we want our our developers to write tests or helping us writing tests if they have to write it in Java. They might be C++ programmers, and they have difficulties in switching to Java, believe it or not. So it's much easier for us to make them write testability code within the client instead, their own native language. Now this is how it could look before. This is a string that will enable the test to put the position of the throb or the little, the thing in the progress bar on the right position. And afterwards, this test interface being implemented, the code that the test automator has to write is only this. Now the developer on the client side has implemented some sort of native code that will actually implement this seek track and put that on a specific position. I mentioned some other things that the test automator needs to spend time in, and it's, for instance, these kind of things like supporting services like our test data service, which is a service that enables us to run our system, which has a state which we don't have to roll back. The databases can be in any kind of state, and we can run our tests independently of that. It works in a way that we describe the characteristics of the data instead of putting it in clear text and whatnot. So what we ask for is, for instance, I need a premium user, needs not to be connected to Facebook, and by the way, we are running against test environment XY set. And the test data service will do a lookup using some backend services to retrieve any data that matches those criteria and pick one randomly and send it back to the test. And also lock that data so that we can't have any other test pulling the same data and thus interrupting the tests. The TRS is a service which both collects data and visualizes it for us. We also have our own lab where we house our hardware for the mobile testing. I would not recommend going in too much in orchestrating and hosting your own hardware. It's very, very time consuming. I would love to have our testing going on more, for instance, for the WebPlayer at Source Labs, but unfortunately we can't play music on Source Labs because they don't support sound, which is a bit sad for our tests. So instead we are having our own server farm which houses our Windows clients and so we can run our web tests on those instead. This is an example of how a dashboard can look like for a team. This is an example for the iOS squad, which is the iPhone squad. What we see here is a lot of green, some red, some yellow, some gray. Now, the rows represent features on a higher level, and the columns are the configuration upon which the features has been run on. Now, if we take the upper left cell, it's all green. It means that all test results that maps against a broad too long, an iPad 2, has been successful. If we go down 2 cells, it's red. It means that all test results that maps has been found that they failed. Yellow means that we have both passed and failed, and gray means that there's no test results at all that maps to the specific configuration. Now, this is a very easy way to get a quick overview of the current status of the system under test. And if you need to do drill downs, you can click on the cells and you will get the actual results, and you can have a view on the results and actually look at screenshots and log dumps and actual data that will help you to troubleshoot the problem. Here are some of the tools that we have been using at Spotify up to date. The YEd tool is an editing tool for modeling the finite state diagrams. It's not an open source tool, it's a freeware tool. It's written in Java and works on every platform, which is nice. GraphWalker is the tool that generates the tests from the models, and it hooks up and connects to the actual code that runs the tests. But GraphWalker is essentially a tool that understands the GraphML model files that you get from YEd and can generate a test sequence from that. That is what it essentially does. It's a Java tool, but we also at Spotify have written a Python implementation of GraphWalker, so you can write your tests in Python and interact with your model directly. We use CQLI a lot. It's an image recognition tool. It's an open source tool from MIT. I think it's very, very nice, and it does its job very, very good. The only drawback is that it's slow, which is expected. Did I mention that GraphWalker was open source? I did now. New Remote is a way to communicate with our iOS clients. It's a library that we link into our testing clients, which enable us to communicate using strings back and forth. We use TestNG, which is a common tool to write unit tests in Java. We use them to organize our tests and to run them. Java is our coding language for test automation. And interestingly enough, we use Jenkins, not as a continuous integration build tool. We use it as a test job scheduler or test job scheduler. That's the tool that launches our tests whenever we need them. So we run the test in 2 ways, either continuously, that's the bug hunting tools, or in conjunction with continuous delivery. So we have another tool that calls upon Jenkins to run a specific critical path test, which Jenkins then runs and communicates back to the test result service that we have. So when we look upon the test, we never look at Jenkins for the results, only the TRS. At this moment, I would like to show you the last video that I have. So this is a video from our QA lab. It's a couple of simulators and a couple of iOS devices. And what we have here is independently running tests. The tests are not actually running on the individual devices. They are running on Mac Minis that is actually running the test, and they are communicating using New Remote to the actual device. Now here we have a login procedure which was successful, and the data is runtime collected from the test data service, and results are continuously pushed back up to the test resulting system. Now things are running a bit slow. We will see that in our TRS, and there the middle one crashed, and the crash dump and everything is sent back to the TRS, so we can later have a post-mortem of the actual problem and see what might have caused the problem. So that was pretty much my presentation.
Okay, thank you very much for that presentation, Kristian. We're now just going to open the floor to your questions. If you haven't typed your questions already, you can do so now. And just while you're typing the questions, let me just bring your attention to our EuroSTAR webinar archive. Here you can view a recording of this webinar, as well as 85 other webinars on a wide selection of testing topics. And finally, the call for submissions to speak at the 2014 EuroSTAR conference in Dublin is now open. The theme for next year's conference is Diversity, Innovation, Leadership, as chosen by Programme Chair Paul Gerard. The deadline for submission is the 14th of February 2014. And for more information on how to submit, please visit the EuroSTAR website. We'll now look at some of your questions now. And let me just open them up here. The first question I have for you, Kristian, is the squad, tribe, and guide structure something new or an existing structure at Spotify? And who implements this?
For us, it's new. I have maybe personally not worked at any other place that has implemented this. It's a traditional cross-matrix organization. I mean, that's not new. But in my view, what's revolutionary, at least, so to speak, is the concept of agile coaches, and agile coaches being in every team, and having and making every team or squad self-autonomous. That really drives the people within the squad to follow their own ideas, how to do things. And I would say it's new to me, and it's implemented at Spotify approximately the same time I entered the company, so it would be 3.5 years old. And it wasn't perfect in the beginning. It's something that has been, it's like trial and error until we found a concept that was really working for us.
The next question I have for you here is, when are the automated tests executed? Nightly, on demand, or just when needed?
Okay, it's both on demand, and those on-demand tests are run in conjunction with the continuous builds. Then we have, and those tests are a little bit different than the other set of tests that are run continuously. They are running round the clock, 24/7. So you can have one test that runs, and when it ends, it will restart 10 minutes later, but it will run on a different configuration, perhaps not Windows 7 Firefox. It will perhaps run on Windows 8 Chrome, and with different data. And it will run continuously. That's a sort of a bug hunting test. Now the critical path tests, those are the tests that we expect always to work. So those tests, we have taken more care into making them really, really robust, really, really stable. So that when they don't work, it's really a signal to the team that we have a problem, we have an action that we need to take care of.
The next question I have for you here is, do you encounter any disadvantages of using non-deterministic FSMs in your modeling?
It depends really. It goes in conjunction with the data we are using. You could end up in a situation where you don't have data to run the test. So the model and graph walker wants to take the test to a specific vertex which it can't reach because of the data is not existing or something like that. Now, we have the fortune that most of our tests are non-intrusive and non-destructive to our production, so we run our tests when we can and as often as we can on production data. So for Spotify, not having these kind of problems, as the question described, is not actually a problem for us.
The next question I have for you is, when will the model viewer be included in GraphWalker?
It will not be included in the GraphWalker unless somebody pitch in and code that model viewer. I made a stab at it, writing some model viewer for in my vacation, and I'm not really satisfied to make that one public yet. But we have to look at GraphWalker as a part of a link in a tool chain, where GraphWalker is just one link in that tool chain, and YEd and Selenium and the new remote and the TRS and everything else is part of the tool chain. I don't expect that GraphWalker would be a tool that would include that much, because one of its strengths is that it's loosely coupled to any other tool. But it would be nice to have an editor that with syntax checking and stuff like that. It's a good question.
And the next question here is, what is the level of granularity that you use in your models? Do you model the entire system with a single model, or do you have multiple models that handle specific functionalities or areas?
Multiple models. So we try to keep our models not bigger than the models that we saw during the presentation. If the model gets too much more bigger than that, we will have problems with the models themselves. Like, well, let's put it like this: what we try to achieve with the models are like, if you ever heard of specification by example. So if you think about a business case or a business flow, that is what we try to model. So the simple one. So keep a model just to playlist. Keep a model just handling the login sequence and not everything. GraphWalker has the mechanism where we can jump between different models. So if we need to log in order to test the playlist, we just reuse the model handling the login, and then just jump to the next model that will handle the playlist. So multiple models, and we keep them sweet and small.
The next question is, does your Python implementation of GraphWalker indicate that the Java version will be depreciated at some point in the future?
No. They complement each other, and the GraphWalker, the Java implementation has the convenience is that it works very well with Java, of course. So any kind of tool Java language makes it easy to just import the GraphWalker stuff and run the GraphWalker from within your code. That's how we do it here. But if you have programmer that would rather write Python, as in the case that we had here at Spotify, they implemented their own version in Python just in order to, because they didn't like program and Java, so they wanted to program in GraphWalker. So it's just an implementation of the GraphWalker modeling syntax. I think they really complement each other.
The next question is, during your test design, what format are your test ideas written in before you get your automation test developed?
It's different. Every tester here at Spotify does exploratory testing. Now that can mean different things for different testers and different teams. I would say that the typically case is either you write your ideas down on a wiki page or mind mapping, or you use some kind of playbook approach. It's different. Again, the teams are self-autonomous, and so are the testers, and they choose different approaches to how to go about their testing.
The next question is, how and where do you store test results?
So all the test results goes into one giant database. It's a very, very simple database. We created it ourselves, but it's very, very simple. It's a key value store with a view table, which means that if you as a test automator wants to add some kind of new data or something that nobody has stored before, it's very easy to do that using this key. So it's one giant database, and attachments are stored as files in the same server as that database. So we're using, I think it's Postgres today, or it's MySQL, I don't remember. No, it's Postgres.
The next question is, do all squads at Spotify use test automation?
No. No, they don't. Some squads are deeply into prototyping and working with new business ideas. So prototyping is not a team that would go so much. They don't even have testing in the traditional sense. It's this kind of test automation which I talked about today is mainly on these 4 platforms. So I would say we divide the squads into platform teams and feature teams. So you would typically find test automation there. Then you would also have other kinds of test automation in backend teams that don't have any client or a client UI to test on, but they do different kind of test automation, which I didn't touch today. But test automators, I would say about 10 teams.
Okay, the next question I have here, it's quite a long question, so if you need me to repeat it, I will. How is communication between chapters and guilds managed when a squad has deadlines to meet? Does this happen at allocated times, and does this ensure approach to your automation is consistent across the squads?
So that's done on a need-to-know basis, or it's on when required. We don't have any formalized way on doing this. We have a release management system in place, which is handled by a release manager that can handle complicated things where teams or squads needs to coordinate and such. There's no Spotify development process as such, and there's no Spotify test process in place as such. It's all very individual in the teams, and yes, that causes problem when it comes to coordination. So that's handled by a structure which we call road manager. It's not very common to have a road manager in place for big releases. That's handled by release manager or projects in a traditional sense, which coordinates the efforts when needed. So it's on a needed basis, so to speak.
Okay, we've run over time there, so we'll just take one last question just to wrap things up. And this question is, how do you deal with parallel test execution? Do you use grids?
Yes, we do. So not grids in a traditional sense. We do have a server farm which virtualizes Windows machines, and we have a lot of Mac minis to do the OS X testing. We use Jenkins in order to run the tests, and tests can run in parallel. In order to avoid conflicts with test data, we use our own test data system to handle that, because the test data system will give, or the service will give the test the data when needed, but it will also handle the locking mechanism for the data. Jenkins is handling launching tests on multiple nodes or nodes that can only handle one test at a time. So that's handled by Jenkins.
Okay, we're going to wrap things up there. And I just want to thank Kristian and Karl for today's presentation. And I'd like to thank all you attendees for attending and all your questions. The webinar is now over. Thank you and goodbye.